Have you ever tried to find someone's longest streak of daily activity from a messy log? That's exactly what LeetCode's longest consecutive sequence asks. One of the Pattern Mastery 100 essentials, and a problem that stumped even experienced engineers at companies like Google, Netflix, and Facebook. In interviews, getting this ON trick is a game changer. Let's apply the basic approach. A strategy broader than STAR because it's designed for breaking down technical challenges and system designs, not just behavioral questions. We're given an unsorted array of integers and asked, what's the length of the longest run of numbers that appear consecutively, regardless of order? For example, 100, 4, 200, 1, 3, 2, yields, 1, 2, 3, 4 length, 4. Edge cases? Handle empty arrays, negatives, duplicates, anything the interviewer throws at you. Suppose you're designing a fitness app. You get a list of dates a user logged workouts. How do you instantly show their longest streak, no matter the order the logs came in? This problem is exactly that challenge. If you sort and count, you get ON log n. Good, but not great. The best solution uses a hash set for O1 lookups and only starts streaks at the true beginning of each run. Num, 1 isn't present. That way, you never double count or waste work, making the algorithm ON. Add all numbers to a set so we can check for any number in constant time. For each number, only start counting a sequence if there's no smaller number in the set. Count up from each streak start, tracking how long the run goes. Update the max streak found along the way. Return the result. Let's walk through the logic as if we're coding together. Let's walk through this solution. The main goal here is simple. Find the longest stretch of consecutive integers inside an unsorted array. If we don't remove duplicates or keep the numbers in order, we can't reliably count consecutive runs. If we store uniques in a set, sort them, and scan for streaks, everything works smoothly. Approach: sorting plus linear scan, ON log n. Time complexity, ON log n. Begins the method that returns the longest consecutive sequence length. If there are no numbers, there's no sequence, so return 0 immediately. Creates a set to store unique numbers. Adds all numbers to the set, removing duplicates. Converts the set into a list so we can sort it. Sorts the list in ascending numerical order. Initializes counters. Longest tracks the best streak, cur tracks the current streak. Start scanning the sorted list from the second element. If the current number continues the consecutive sequence, extend the streak. Otherwise, the streak breaks here. Update the longest streak if needed. Reset the current streak to 1. Ends the break handling block. Ends the loop scanning all numbers. Returns the largest streak found, either the longest stored or the final streak. Ends the method. And that's how the longest consecutive sequence algorithm works. Efficient, simple, and elegant. Now let's verify that this solution behaves correctly with the provided test case. This array contains unsorted numbers with duplicates removed automatically by the set later. It matters because inside this scattered list is one clean consecutive sequence, 1, 2, 3, 4. The algorithm removes duplicates, sorts the numbers into 1, 2, 3, 4, 100, 200, then scans through to count consecutive streaks. The longest streak is 1, 4, which has length 4. This makes perfect sense. The longest consecutive run in the input is 1, 2, 3, 4, so the correct answer is 4. So our solution checks out, the result matches the expected behavior, and the algorithm handles this test case correctly. Let's walk through this solution. The main goal here is simple. Find the length of the longest consecutive sequence of integers in an array. If we scan blindly or recount the same sequence many times, things break in terms of performance. If we use a set to detect only the true starts of sequences and walk forward, everything works smoothly. Approach: hash set plus sequence start check, ON time complexity, ON. Defines the solution class that LeetCode will use. Starts the method that will return the longest consecutive sequence length. Creates a hash set to store all unique numbers for O1 lookups. Adds every number from the array into the set, removing duplicates. Keeps track of the longest consecutive length found so far. Iterates through each unique number in the set. Checks if n is the start of a sequence, no previous number n, 1 in the set. initializes the current sequence length as 1 and sets cur to the starting value. While the next consecutive number exists, keep extending the sequence. Moves to the next number in the consecutive chain, increments the length of the current sequence, ends the loop that walks forward through the sequence, updates the global longest streak if the current one is larger, ends the block that handles a sequence starting at n, ends the loop over all numbers in the set, returns the length of the longest consecutive sequence, ends the longest consecutive method, ends the solution class, and that's how the longest consecutive sequence algorithm works. Efficient, simple, and elegant. Now let's verify that this solution behaves correctly on the provided test case. This input is an unsorted array with some duplicated values, like 0 twice. It matters because buried inside it is a long consecutive run from 0 up to 8, and the algorithm needs to find that full stretch. Short reasoning of how the algorithm processes the input and what it checks for. All numbers go into the set, giving 0, 1, 2, 3, 4, 5, 6, 7, 8. For each number, we only start counting a sequence if there's no n, 1 inch the set. That's only true for 0, so from 0 we walk forward. 1, 2, 3, 4, 5, 6, 7, 8. That's a sequence of length 9, so longest becomes 9 and no later sequence beats it. This output makes perfect sense. The longest consecutive sequence in the input is 0, 1, 2, 3, 4, 5, 6, 7, 8, which has length 9, so returning 9 matches exactly what the logic is designed to compute. So our solution checks out, the result matches the expected behavior, and the algorithm handles this test case correctly. Let's have a quick recap. We're given an unsorted list of numbers, and we need to find the longest run of consecutive integers, no matter the order. Conceptually, it's about identifying sequences within disorder, finding those hidden streaks that form continuous ranges. It's a perfect test of both logic and efficiency. A sorted approach works but costs O(n) log n. To do better, we use a hash set for constant time lookups and start streaks only when we see the beginning of a sequence, meaning, when num. 1 isn't in the set. This clever shortcut prevents wasted work and achieves true O(n) performance. The logic flows like this. Add every number to a set for O(1) lookups. For each number, check if it's the start of a sequence. If it is, count upward until the streak ends. Keep track of the longest streak found. At the end, return the maximum streak length. We built this logic step by step, ensuring each number was visited only when necessary. The code ran cleanly and efficiently. We successfully executed it on LeetCode without any errors. We tested across various cases, scattered numbers, duplicates, negatives, even empty arrays. Every test passed perfectly, and the logic held up across all scenarios. The key takeaway? True optimization isn't about fancy syntax, it's about seeing structure where others see randomness. Once you understand how to detect starting points, you can handle any streak, sequence, or continuity problem with total confidence.